your Bing.
All right. So hi, I'm Colin from Shopify, and just going to talk a little bit about our experiences with early hints and some of the lessons that we've learned along the process, and some of the editorial as well I'll share at the end. Just a reminder that the information I'm sharing, the data I'm sharing today shouldn't be used for any investment or financial insights. The data is a function of some sampling, so for illustrative purposes only. So early hints, great stuff that during Black Friday, Cyber Monday last year in 2021, we saw through synthetic testing, page improvements for our merchants across the base, and in an aggregate sense, over 500 milliseconds faster LCP at the P50 when we enabled early hints through that. So a great success. Thank you very much. We'll use the rest of this time to look at dogs. All right, so let's talk a little bit about the problem. I appreciate the sympathy laugh.
I appreciate it.
The one core challenges that we have is with our merchants, they can build websites from off-the-shelf components to full design of their store experience. And in many of the cases, if not all the cases, we have the classical challenge of head-of-line blocking, where resources are discovered after payload is loaded, many cases requiring that TLS tax to be paid as TCP connections and TLS connections are renegotiated, and then follow-on resource discovery as the browser loads, leaving a large gap of time where the browser isn't as efficient as it ought to be. And why do we care a lot about this? Just to put yet another data point to everyone's. I mean, I don't think anyone here needs to be convinced, but for us, that first engagement is of paramount importance, because we have seen when, on average, that first page experience for the buyer is when it's 10% faster, then there's a 7% increase in conversion. So the first page experience is important in the long journey of the user experience. For completeness sake, there have been past attempts at filling that gap with resources, getting the browser to know what to do sooner. Of course, we've gone through H2 push. Please don't do YouTube searches with my name and H2 push. And obviously there's challenges with H2 push that we well explored with cache and integration challenges. Resource hints have been better because integration into HTML markup is great, but the mileage does depend on how discoverable the resource is to the renderer. Many of the cases, and I'll talk about this a little bit at the end, where we're competing with the renderers thread discovering the resources, and so the mileage really is more beneficial when it's an indirect resource, and so it's a lot of developer implications. I don't, just for anybody who's not familiar, early hints is just intended to be an HTTP 103 response that ahead of the actual 200 response, so that the browser can get a jump on making requests for CSS and JavaScript in that in-between time. So some of the challenges that we had going in, I know it's been said in other contexts, but adding HTTP headers are hard. So adding the link header is hard, and adding another HTTP status is also hard. And there's multiple layers to that, hard for developers inside of infrastructure, so on the platform side, but also for more specifically for our developers. So the developers in the Shopify larger ecosystem, the entrepreneur developer, adding HTTP headers is notoriously challenging. Complicating is also, how do you relay HTTP 103 through a CDN? Because if it's a shared TCP connection on the backhaul, how does a 103 response reflect out? Is it for one of the responses that this connection is established for, or is it for all of the connections? And that relaying is a notorious challenge. And then, of course, browser support for HTTP 103. Additional challenges, specifically on the Shopify side, I call it technical debt. Best practices that pre-existed, specifically the use of a static resource domain for all of our JavaScript and CSS. So we use cdn.shopify.com as a separate resource, cookieless resource. That was a best practice in the old days and has been built on over the last 15 years. And unwinding that has a non-zero amount of effort. As I mentioned earlier, our merchants can build content, build sites, highly dynamic and personalized, so it's not cacheable in the first place. And there's varying levels of control depending on where you are in that ecosystem of our ecosystem of developers, whether you're providing an app or actually building the whole site. So just to run through the quick implementation on the Shopify side, what we ended up being able to do is instead of exposing APIs to add headers or add the HTTP 103 response, we focused on developing APIs that implicitly added the rel preload, both in HTML markup, but also as the HTTP header. The intention is that we want to give developers the tools to accomplish the outcomes, add a hero image, add style sheets, and signal what their intention is, and use that signal to then, adding an image tag and using that to add the link rel preload in both either markup or HTTP header, but not force the developer to actually add those as two separate steps. So just where their intention is, signaling that this is a hero image, it's above the fold, and then we will add the preload attribute. We also globally added the rel equals preconnect. So whether you change the markup or not, we also added rel preconnect for the link header. And also, as a side note here, we also limited the use of hosts for preloads, in that and this is partly in the initial implementation, uncertainty of what's the implication. So we wanted to scope it down to limit it to preloading resources that were hosted on Shopify resources and not third parties and so forth. And also limited the number of preloads, which is also in the initial step and has been changed. So to achieve this kind of markup, the link header in HTML, these are the kind of syntaxes that you would see. So for instance, the last one here, if you wanted to put as a web font, mark it as an asset URL, mark it as a preload as font, or the middle one, mark it as an image tag. And that image tag would actually emit the HTML image tag, but also add the preload HTML and the preload link header. So keep the context within the markup with the intention, and then the platform will take care of it. This is snippets of example code from our liquid language, but we also have this in Hydrogen as well in similar fashion. On the what made this possible was in the Cloudflare integration. While we would send the link header as a part of the 200 response, Cloudflare would take that 200 response and cache just the link header aspect, so that on a subsequent request, they would then be able to generate the HTTP 103 response, taking the link header from the previous request. This solves that problem of integration and the reflection of if it was 103 passed from the origin, who's the actual target, and it solves the problem of having to manipulate and manage specific code in the CDN. I'll go into detail a bit later on, but also we had to isolate this to HTTP 2 and 3, as well as doing user agent detection in the isolation. So instead of the typical use case of the 103 and content coming from the server, in our CDN environment, we had that first request, so the GET going through the CDN, going to our backend origin, and that link header on that first 200 requests coming back on the second request, that link header being generated and cached results in the 103 response, and away you go. So that solved the integration with Cloudflare. On the Google side, M95 introduced behind feature flags, early hints, and subsequently with a bunch of other fixes in M97 ahead of Black Friday. With a field trial through Black Friday, we were able to enable this feature flag, and that's where all of our data that we gathered. So it's a ability to do an A/B comparison in the cohorts. Some notable failures in this process. So first off, well, you can't see this. So we enabled this originally just scoped to HTTPS, and thinking that that will eliminate the problems of middle boxes and things like that. Turns out there are proxies everywhere, and these proxies all share code that akin to this one. This is from mod proxy. This you can't read a small space, but there's a giant fix me that's highlighted at the bottom. And this code comes from like early 2000s. It's basically we don't know how to deal with 100 series, so we just punt and we'll just return the payload as it comes. And this broke some of our integration partners because they had, one specific case, they were relaying the original content, doing some transformations for the merchant, and then spitting out content, and now they were getting 0 body payloads because of mod proxy. We found the same thing in pretty much every one of those typical proxy stacks that might be used, and it all has very similar feels like this code was copy and pasted and has proliferated for 20 years. So that forced us to isolate the use of early hints to HTTP 2 and 3 connections, because this is, this snippet particularly doesn't apply. It only works in HTTP 1 connections. We also ran into challenges with Lighthouse as an example, because of the version of Chrome that it was attached to. It was running the same thing where the Lighthouse inspector was basically looking at the first response, seeing 0 bytes because the 103 didn't have a payload body, and so it also had failures. Again, so this is why we had to start using user agent isolation to focus it onto Chrome, M95, and later in this scenario. So results, as I mentioned, great results. So this is a synthetic of Gymshark, where you can see the movement of the largest contentful paint. This is as a synthetic, things are being a little bit exaggerated here for illustration, but across the board, we definitely saw that movement between those that got early hints, particularly with the pre-connect header, comparing that with the baseline. So in here, I've got an aggregate view here across all the different platforms, and these are box plots, so plotting the P1 to P99. The box itself is P25, 75, and the line is the median. So across the board, the earlier hints cohort definitely saw a much improved LCP, in that P50 comparison at a global level was at 500 milliseconds. So nothing to sniff at. And you can see as the candlesticks, the box plots, they have all kind of increased. There was a challenge here in how we collected or isolated this data. And I'll dig into that a little bit, but we've had to go through a lot of extra hoops just to be able to isolate the 2 cohorts, because it's unclear from first blush if this was a client that had the field trial enabled and could listen to early hints and took action on that early hints in the request flow. But before I dig into that, just same box plots, copy and pasted. They're based on different geographies. So top left, you have North America. You've got Europe and Central Asia. So I've looked at a continent level to reevaluate this. And as you actually look at it in more Eastern countries and continents, you definitely saw that improvement in LCP much greater across the board. So good results across. The interesting piece here, and I'm going to put some footnote on this one, because this is the time to first byte plot. So look at time to first byte. We saw time to first byte actually got worse. Now I put a footnote here. I've had to rerun this data with the insight recently about response start being triggered by early hint. So this data is not as accurate because I think it's more of an A to A, but looking at even time to last byte, we saw a similar result. So that's why I've left it in here, where the time to last byte and time to first byte got slightly worse with pre-connect, with early hints, but measured in tens of milliseconds, not hundreds of milliseconds. So this makes some sense because of the network adapter having to now do other scheduling on the wireless plane and having to make other TCP connections and busy while it's waiting, now getting queued up results. So this makes intellectual sense, and at the cost trade-off of delaying by 10, 20 milliseconds in exchange for 500 milliseconds was definitely a good trade-off. Some general lessons, though. So the ecosystem is messy. I mentioned this because of legacy HTTP 1.1 proxies, mod proxy in particular, but also all of the copy and paste of mod proxy, that code. We had to isolate that to HTTP 2 and 3 to avoid that. UA sniffing was still needed because of Lighthouse and some incompatibility, even where there was HTTP 2 or 3 supported. To date, I think Lighthouse was the only major example where this was that we identified, but we're still isolating that just for good practice. Today, I believe it's isolated to Chrome 95 and greater, curl, and a bunch of the other debugging tools as exceptions. There were some inconsistencies with the implementation of the link header, particularly like image source set, image sizes, because as we emit the link header, it had to be post-processed by CDN and then emitted out later, and not all the attributes that we thought were being aligned or exposed. And the questions there, I think, about like how do we make sure this is consistent in the RFCs or in the spec for the link header. In our case, we do believe that pre-connect was what moved most of the gains because of that TLS tax at the front that we saw globally. But we did see a lot of different adoptions, and the adoption in the developer community was pretty wide. From those that aggressively just added preloads, once we opened it up, they added preloads for everything, which is unfortunately not that uncommon, as well as we gave a mechanism for people to add a preload as a handcrafted, saying that here's a resource. I do actually want to mark this as a meta tag for preload. And we saw a number of those cases. The challenge with that, of course, is that with the handcrafted particularly, they get quickly out of sync, and it's like every other handcrafted scenario, which we're trying to avoid in the first place. But of course, developers do take advantage of that. Credentialed connections continue to trip up. We've had to field a number of requests or concerns about this, where trying to preload this, but of course it's on a credentialed connection, and so the use of cross origin, it's a continued challenge for our developer ecosystem. And that's a pretty wide ecosystem out there. And of course, HTTP priorities definitely proved to be valuable. The work that Pat shipped earlier on to reprioritize resource hints to make sure that they got deprioritized ahead of once the renderer thread goes. Some of the outstanding issues, we talked about this, I think, 2 weeks ago. Response start is ambiguous, and I'm hoping that we can land some of those changes to make response start more consistent with previous assumptions that response start was when the authoritative response landed. Obviously, right now, it's a little ambiguous, and in the current implementation of Chrome, response start measures when the early hints land, which is what I mentioned about getting the data becomes a little messy in trying to tease out what the true time to first byte is. That's kind of related, actually. We did add the initiator type of early hints into the resource timing, but that also is proved to be a little bit racy because there are many situations where it would just say initiator type as link instead of early hints, and that's just a function of when it actually landed on the network stack, and some oddities there. We'd like to still, there's still some conversations that Gnome's been driving about sub-resources and worker usage. This is where it can get really useful when you, particularly for single page applications, to be able to do some of that loaders, signal some of the opportunities for early hints there. And the last two items here, so browser adoption obviously is continued outstanding. And relate to last conversations about the reporting. So reporting of orphaned requests is still unclear. How do we get these orphaned requests? Because this code that merchants can deploy to signal the early, to signal resource hints of any kind, whether preload or pre-connect, that could be embedded in loops and fork, so we can't see it all the time. And particularly where merchants have tried their best to follow whatever YouTube tutorial they're doing, and they've just hand coded a bunch of stuff, they don't get the feedback loop that they're causing the buyer, the user agent to actually download resources that are never used. So the adoption is so that feedback loop would be a nice to have. And so finally, some final editorial here. As we've mentioned a number of times already, resource hints still require a lot of context and developer intention. Like it's not a silver bullet by itself. With the use of early hints, we are using that time in the margin. So even if they don't have a lot of that context, we actually are making some benefits. But as I mentioned, most of the gains that we saw were from pre-connect. And that's what I want to really emphasize here, that the value that we got here is that while the right solution is for us not to have this resource domain, CDN Shopify, and we should collapse it, and that is work that is undergoing. It's 15 years of architecture that needs to be unwound. It doesn't happen. And so I think the most beneficial part of early hints that allowed us to create a new compensating control that allowed us to get some of the performance gains while we buy time to rebuild and re-architect. So this kind of philosophy, I want to encourage the community to do more of, where we can get around some of the old bugs, if you will, while addressing that. Yeah, the right solution is to blow it up and rebuild, but we can make strides in between time. And that's all I've got. So thank you very much. Let's look at more bugs. Where's
Thank you.
Oh, there's
Your dog.
It is my dog. Yeah, wearing my shades.
Yeah, I noticed the shade.